and today we're going to be measuring the volume of this rock. Since we can't measure the dimensions perfectly, we're going to use the Eureka jar to measure it. So first we have to put the rock inside the jar, and then however much water overflows is equal to the volume. Okay, so let's begin. Okay, now the teacher will help me take the bowl out without spilling anything.
So, and we first take some water from here. Oops. Minimize spilling. Here's your overflow.
The water. So now we're going to measure this very carefully without spilling anything.
You can take them. Yes, please, directly.
So now we know that the volume of this rock is 140 millimeters. My name is Delphine, and now we will measure the stone's mass with the laboratory's scale. We put it on a flat table and we turn it on.
Now she's waiting for it to calibrate.
415.0. Okay. Yes.
Yeah, grabs.
Okay.
My name is Barun. Now I will find the density of this rock, and I will do mass per volume. Now,
$2.96 approximately.
Approximately 3, actually.
Yeah. Gram per milliliter.
Okay.
So we found the density.
yeah, we find all of the density, volume, and mass.
Using the methods we just used, if we measure the water's density, we can predict if an object will float or if it will sink.
By calculating the density.
This is my submarine. Its density is less than the water's density, but we want the bottle to sink because the submarines sink all the time. So we suck the air in the bottle out of this hole.
Okay.
The water gets inside of the bottle from these holes when she sucks in the air out of the bottle.
It sinked. Now it's gonna come out. So I'm gonna blow the bottle, air into the bottle.
Whoa!
So the kids can change the submarine's density They can.
Hocam ben yaptım ki.
Oh, it's hanging there.
There are 3 different types of gates. This is the OR gate, this is the NOT gate, and this is the AND gate. So the OR gate, if you push from any side, it still goes forward. But the only time it doesn't go forward is if you don't push it at all.
Zero or zero situation.
The NOT gate, if you put in 0, it becomes a 1 on the other side. And
Can you show us by example, by pushing it?
This one doesn't work, so we'll look at this model. So right now it's at 0, but it shows here on the other side that it's at 1. And if I push it to 1, it goes to 0.
Yeah, excellent.
And the AND gates, you have to push it from both sides at the same time. Because if you push it like this, only one side, it won't go forward. But if you push it at the same time, it goes forward.
So it only works on 1 and 1 situation, not 0 and 1, 1 and 0, and 0 and 0.
In our everyday lives, we use the decimal system, which has 10 numbers in it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But when we're communicating with computers, we use the binary system, which only has 2 numbers, 0 and 1. Basically, 1 means yes, or like turned on, and 0 means no, and turned off.
So it makes the communication with computer simpler.
Much more simple.
Yeah.
And if we were to add, for example, 1...
Oops.
1 plus 1 in binary, it would equal 1, 0.
Just like 5
Just like,
plus 5 in decimal, right?
5 plus 5 in the decimal system equals, 10.
Yeah. Okay.
So a half adder, which is one of these, is made up of NOT gates, AND gates, and an OR gate. If you combine 4 of these together, it creates a huge calculator, basically. So basically on this you can do 1 plus 0, which makes that 1.
It
Then-
went long.
Yeah. And then, so now I'm going to add 1 and 1. You have to push both of them at the same time.
You gotta push them right.
So now this became a 1 and this became a 0. So that means the answer is 1, 0. And if you wanted, you could combine a bunch of these and basically be able to add anything together. Thanks for watching.
Thanks for watching. We will be waiting for your next video.
Goodbye.
Goodbye.